Hi, my name is Dr. Nalinda Somasiri. Previous video we discussed two models, which is logistic regression and then the decision tree. So we managed to get a better accuracy on the logistic regression, which is 0.75, and for the decision tree we got accuracy of 0.55. So compared to the two models, the logistic regression gave us a good prediction. Now what we're going to do, we're going to do a hyperparameter tuning on decision tree model. So the plan is to get the best parameters for your model that gives the better accuracy. So that's the plan. Before I get into the hyperparameter tuning on decision tree, I'm going to quickly show you what this hyperparameter tuning is. So in here you see grid search on the left hand side, and the right hand side you will see the random search CV, and we'll identify the difference between these two searching algorithms. The first one is the grid search CV. As you could see, the hyperparameters are there on the black dots. So basically in grid search, the algorithm will run through each individual parameter, right? So first of all it will check on this, and then it will check on the second dot, and then it will go back onto the third dot and then the fourth dot. So it will go in a direction, one direction, right? And then it will pick all the dots, the parameters in the model, to get a best parameter for your model that gives you a better accuracy. On the right hand side, it's kind of different to the grid search. It doesn't go on a single direction as the grid search did. Basically what it does, so it will have random directions. So initially it will go and search this hyperparameter, and then it will go on that and go back onto the third one and then the fourth one to find the best parameters for your model. So this is the difference between grid search and the random search CV. In our model we're going to use random search CV. Of course you can use the grid search CV for you to understand. I'm going to choose random search CV on this model. We'll go back to the model development now, and we're going to use this hyperparameter tuning on the decision tree model. Remember we got 0.55 accuracy on our decision tree model before. So let's see, we're gonna get a good set of parameters this time. Here you see when we created the decision tree object, we have a criteria, entropy, random state 0, and these are the parameters that we use. But here we're going to identify the best suited parameters for our model. So let's get this model going. So let's use this code snippet to identify the best parameters for us to use in the model. Here I imported some of the libraries. So first of all, we imported the decision tree classifier. Of course we have created this earlier. And also we're going to use the randomized search CV, which is the search algorithm we're going to use for this type of problem. And also we got it from SQL and model selection library, right? And then we're going to create a parameter dictionary, right? So we're going to use maximum depth 3, the maximum features, which is going from 1 to 13, and the sample size of your decision tree, it's going to be between 1 and 13. That's how we set it up. And remember the criteria we used before is the entropy. If I go and check it again, so here we have another choice called Gini. So we need to identify whether which criteria is best suited for this model, and we're gonna put Gini and entropy here for us to find the best one. Right, in here secondly we're going to use the decision tree a model here. So we basically we put a model object tree. And then we're going to create a random search, and these are the parameters we fed into the random search algorithm. Tree, of course, that's your object for the model, and then the dictionary of the values that you're going to use as your hyperparameters. In this case, maximum depth, maximum feature, minimum sample of leaf, and then the criteria, Gini and entropy. So we'll feed that parameter dictionary in here. Right, so we got the parameters within the random search object, which is called tree CV, and we're going to use xtrain and ytrain to train the model. We're going to train tree CV.fit, and we're going to train it using this command. Let's see what are the parameters that we get from this, right? So you see these are the best suited parameters for this. The criteria, entropy, right? And the maximum depth is none. The maximum feature is 7. The minimum sample leaf is 1 in this case. So so from here we get 1. The maximum features is 7. And from Gini and entropy we have a better choice here. So entropy, which is the same thing that we used before, so and that gives you an accuracy of 0.63 compared to the 0.55. It's much more better. So if we were to use this model parameters, we could have got better results in the first place, but here we have the optimized parameters. Let's go and do a bit of prediction on using this new model, right? See how it works. So at the moment we're going to use tree CV, which is our model, and predict using the test data, and we're going to assign that to a ypred. And also I'm going to visualize using a confusion matrix. I took it out because we already called that on the previous example, so we don't need to run it again. So we're going to use the confusion matrix using ytest and ypred, right? And we can use the same code that we used previous models on the last video. So we're gonna use this figure values in here, and then the heat map, of course, and we would see the prediction on here. So on this, so at the moment well, it's true, it's kind of varied here, right? So it's 866 before, now you have 7677, better accuracy, 0.63 than the previous one. So, and again, so this search we have done using the randomized search CV, but of course you can use the other search algorithm that I use, grid search. Anything you could try it, but for this particular example we use the randomized search to find out the best suited hyperparameters.